All right, off we go into Python land. I'm excited for us. So let's learn a bit of Python today. And the first part of using Python is installing Python. So I'm going to walk you through that. These computers, believe it or not, when they restart, everything gets like wiped out. But you are allowed to install programs on these computers. So I'm going to show you how to do that. Or if you're on your laptop, you can follow along on your laptop. But you can just search for like Python download on Google. Or you can go here, python.org/downloads. Just get here somehow. And let me make my zoom go down there. How about that? And then you'll go to the Python page and it'll be like, do you want to download Python? And you say yes. Just click it, download Python 3.11.2. Version 3 is the important one. Or you can just search Google for download Python. It'll take you to the same place. Click download Python 3.11.2 and you'll be like, save it, and then you'll install it. And yeah, let me walk you through that idea. Double click. So yeah, please install Python. Just say install now. Default settings are fine, I'm sure. And this will install Python on your computer if you don't already have it. So please do that, and let me know if you have any questions about how I'm doing this. I just click the download button, and then click the installer. I definitely want you to get this installed on your own machines at home too. There it goes. So it's trying its hardest. So that'll complete eventually. And one thing I should say is, like, if you are stranded without a computer one day and you need to do your Python assignment, there are websites that let you write Python online. Like, I'll give you these slides eventually, and you can click on these links. But for the things that we want to do in Python, these websites aren't going to really cut it very well. It's going to be very slow for the stuff that we want because it's like running it in your browser, which is just not the most efficient place. So I encourage you to install Python on your own computer, and it should all work out. Okay? So this is taking its sweet time on my computer because I've got a bunch of stuff going on right now. But I think your giant towers sitting next to you are probably done with it by now, right? But yeah, it's going to be done soon for me, and then I'll show you what's going on here. Oh, my fan turned on. Space heater right now. So yeah, just get Python downloaded and installed, please. And I'll assume yours is done before mine. So once mine finishes, I'll go to the cool stuff. Hey, all right, setup was successful. So let me delete the installer so I don't have to worry about that ever again. And we'll go from there. All right, so now that we have Python, let's open. What in the world is Python? So I would like you to open up the program called idle that got installed. There are multiple programs that just got installed into your start menu or your applications folder if you're on a Mac. But you can click search, or you can just scroll down to Python. But you do not want to click Python, which is counterintuitive. Do not click Python. That's not what we want. I would like you to click idle in all caps. So click that one and open it. Or you can just search for idle, and it'll be this one. All right, make sure you did the Python 3 version. Python 2 is too old. And when you open that, this will give us a little window where you could start typing. It's like, hey, do you want to type here? You can do that, and I can start typing things. So this is a program called idle, and what it's showing me is something called the Python REPL. All right, so this is the REPL that we just opened. It's an acronym. And it stands for Read, Evaluate, Print Loop. A lot of programming languages have this. Python is one of them. So REPL stands for Read, Evaluate, Print, Loop. So what it does is you can type in the REPL single lines of Python code. You don't write full Python programs in the REPL. You make a brand new program file for that, and I'll show you that later. But you can you can do quick math and stuff. You can do simple lines of Python in the REPL if you just want to do a quick answer and figure out the result. So for example, I can type into the REPL 2 plus 2. And if I hit enter, Python will run it because 2 plus 2 is valid Python code, and it will figure out the answer. And it prints 4. That was our first line of Python. It's not fun. So what did the REPL just do? It read my 2 plus 2, right? Read. It evaluated it under the rules of Python, which are essentially the rules of math for this line. It evaluated it to 4, so it did that. Then it printed the answer 4, and then it gives me a brand new prompt to do this all over again, type a new line, get the answer there. 2 times 2, again 4, star for times. See that? So it's going to loop around, and it will let you do as much as you would like. So it's very nice to use Python instead of a calculator sometimes. I just open it up and run some lines. Okay? So let's see here. So that's the REPL, and I'm sure you can think of fancier mathematical things to do. Like 2 times 5 plus 47. Like, it'll do it. It'll read your text, evaluate it to the answer, print the answer, and then it's going to loop and give you a new prompt to do more lines. All right? So that's how it's working. Any questions about that so far? You'll get plenty of practice, I promise. That's the beginning of Python. So yeah, let's zoom out and talk about what in the world is Python. Like, why am I teaching it to you? It's a very, very common programming language. It is similar to Scratch in many cases, in many areas. All programming languages are similar to each other. This is a new one. Python, though, is not a graphical language. It is a text-based programming language. So you write lines of text, words, not dragging things around to write code. Okay, so instead of like a bunch of blocks in Python land, like this is thing 1 and this is thing 2 in Scratch, right? And then those things happen in order, 1 first, then 2. In Python, you write it like this. You write a line of code that represents thing 1. And then right below it, you press enter and type a line of code to do thing 2 in that order. So instead of dragging blocks all around, you're writing lines of text, and they're in order of what you want to have happen. All right? And then instead of dragging things, like you could drag all that into like the body of an if-else, for example. Like here's an if-else. You can drag all that there. Instead of that, in Python, we're going to use indentation. And we'll get into that later, okay? So, yeah, code is not blocks anymore. You don't drag them around. It's just lines of text. This is just me typing text, pressing enter. In Scratch, if you want to have 2 things happen, right, you put them on top of each other. You stack them. Same thing happens in Python. It's just you put those 2 lines on top of each other. You put those 2 lines right after each other, essentially. All right? Yeah, so that's the setup. That's how Python's going to work. It's all text-based. And then every time you write a valid line of Python, it does a specific thing. Just like if you had a block, it did one specific thing. Like 2 plus 2, of course, is going to do that math. This is going to do that math, whatever I typed and asked it to do. All right? Every valid line has a specific meaning. Scratch was so nice to us, it was impossible to write a program that was invalid. You could probably get an infinite loop or something weird like that, but you cannot have a bad Scratch program that won't even run. All right? In Python, you can. You can speak Python incorrectly because it's just text. You can make a typo, right? And then Python's going to give up and be like, what in the world were you asking me to do? I don't understand you. So that's a new kind of error that you'll see in Python. So like if I just say 2 plus, and I forgot the other thing, like this is impossible in Scratch, right? You're forced to give both sides of the plus. In Python, you don't have to. You can mess up like this. And it's like syntax error, incomplete input. So you can see errors in new places in Python. So that's the first thing. And then, yeah, the Python, and it's called the interpreter. That's the part of Python that's running your code. It's like reading it, translating it into stuff that your computer knows how to do. It's called an interpreter. It's interpreting your English-like text into CPU instructions, more or less. And it's going to yell at you when you make those errors. All right? Any questions about any of that? Still good? Obviously, there's more to it than simple math, but this is the first few lines that are easy for me to teach you. Okay? All right. Let's see here. If we're good to keep on moving, let's talk about just all of the mathematical operators. Let's just get them all out there once and for all. So it's star for multiplication, like 2 times 3 gives you 6. It's slash for division. So it's like 5 over 2 is 2.5. It's going to do that division there for you. Remember that percent sign from my binary conversion lecture? that computes your remainder. It's called the modulus operator, or the modulo operator. There it is. And so when you say something on the left modulo something on the right, that's going to compute the remainder for you after dividing x by y. Remainder after dividing x by y. All right, so 5 over 2 is 2.5, but 5 mod 2 is 1, because you divide 5 by 2, it goes in twice to make 4, but there's 1 left over. That's your remainder, right? 4 mod 2, that's 0. It goes in perfectly cleanly. There's nothing left over, no remainder at all. All right, is that coming back to us? So that's remainder, and then let me just make this smaller so that I can show you the window as well. You can do double star. Double star stands for to the power of. It's not the caret character like you might think it is to do powers. It's double star. So 2 to the 5, that's 32. 2, 4, 8, 16, 32. Okay? So that's for to the power of. Do not accidentally think it's that caret operator, which is a mathematical operator. It just does not do anything that you think it does. It gives you back 7. That is not the right answer. You'd have to wait till CSCI 40 to understand what the caret is doing. But double star for power, right? Any questions about that? It's just read and evaluate and then print it. This is the REPL. This is not a real program yet. It's just me writing individual lines of code to Python. This is not usually how you write a Python program. We'll get there in a second. All right, let's see here. Yeah, if we're good to keep going. I know there's going to be a bit of new information today, so please stop me at any point. It's tough. This is me teaching you a new language. You know how hard that is, assuming you've learned another language in school, right? Another human language. So one thing that's very, very important, and I kind of touched on this a slight bit in Scratch land. Scratch didn't really care about this, but in Python, we really have to worry about the types of the things that we're using, all right? So there are different kinds of types in Scratch, both in Scratch and in Python, and you can ask what the type of a thing is in Python by wrapping it in a type, in the word type and then some parentheses. If you just put between these parentheses what you want to know the type of, Python will tell you. So for example, hey Python, what is the type of 42? What is the type of that? It's an int, it says. Hey Python, what is the type of 3.14? That's a different kind of number. It's a float. That one has decimal places. So let's talk about these things, because the type really tells you what you can do with something, and so it's very important to understand the differences. So think of a type like a cloud. Here's the int type. Int stands for integer, which means whole number. So things that live in the integer type are whole numbers, all right? The int cloud can only hold whole numbers. 0, 42, 1. Negative whole numbers are fine. Negative 42. Those are all integers, or of the int type in Python, right? Those hold whole numbers. And likewise, the float type stands for floating point. If you've heard of that before, it just means that you have a decimal. There's the point somewhere in there. It gets to float around because you can use scientific notation. Float. The float type holds numbers with decimal places. So 3.14. You can hold whole numbers there too, like 2.0, but the 0.0 is apparent. It's specified that it's a floating point number. It's a float. Negative 23.145. That's also a float. So you see the difference between these two types? One holds decimal numbers, the other holds whole numbers. Things between quotes are called strings. Remember that? String is a bunch of characters, and that type of that is string, or str for short. But the str type holds things between quotes. It's you don't have to use double quotes if you don't want to, like hello. Those of you coming from C++, this might scare you a little bit. But you can say between double quotes something. You can also say between single quotes an entire string, a bunch of characters. Python doesn't care. Python does not care. It considers both of those to be strings. So for example, hey Python, what's the type of hello between double quotes? It's a str, it's a string. What's the type of hi between single quotes? Again, it's a str or a string, right? And now the whole point of me teaching you these differences of what types are is so that I can show you how Python uses those types when you perform operations. Plus and star, for example, work on strings. Watch. Just like you can do 2 plus 3 with ints, right? Or 3.14 plus 5.67 with floats, you can use plus on strings. So like hi, space, and then a plus, and I can use double quotes this time because it doesn't care, plus a mom. And this creates the string, the bigger string, hi mom. You see how it's doing that? The plus operation did a different thing on strings than it did on numbers, right? 2 plus 3 is not 2, 3. It was 5. That's because it was for ints. That was plus on ints. Plus on strings, though, is going to give you just those characters in order. It's going to give you a bigger string, all right? You can also use star. So like, let's see here. Blah, you can do that 5 times, blah times 5. That gives you blah, 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 blah. So you can use multiplication with a number on a string as well. And obviously that's very different than 2 times 3. Yes? Do you see how types are important and they're dictating what we can do with values of those particular types? So ints are whole numbers, floats are decimal numbers, stir is string, like strings of character beads on a bracelet or something, and plus and star work on strings. But when you multiply a string by an integer, that gives you a completely different answer than an int by an integer, right? Multiply those two together. So though the symbols for the operations are the same, given different types, they do different things. Any questions about that? That is not something we had to worry about in Scratch. They were given different names in Scratch. You couldn't have messed up. Now you can. Now you get different answers. All right. Probably the most important thing for me to tell you right now is strings are characters. 5 plus 5, the strings added together, gives you 5, 5, the string. Yes? Different from 5 plus 5 in int land. The types are very, very important here. Hopefully you understand why I'm spending a lot of time on this. It takes a while to sink in. Okay, are there any questions about any of this? So that is, I think, the start of it all, and I'll give you some of these symbols over here because I'd like you to try now. All right, let's see here. You don't have to type this anymore. I just want you to help each other figure out if you can get this. But here's my scratch work over here. I would like you to do this. Figure out how to create this string. Hello, space, hello, space, hello, space, hello, space, and then hello at the end, but without a space. So this is 42 hellos total. .42 hellos, the strings total. There is not a space right here. You don't put an extra space at the end. So see if you can figure out how to create this exact string of hello 42 times with spaces in between each hello, but not at the very end. All right, so that's going to be a little bit of a trick. You can add multiple strings to each other, like 5 plus 5 plus 5 will give you back the string 5, 5, 5. You can put things between parentheses. You can use all those things that I was telling you. See if you can figure it out. So again, if you wanted it 3 times, for example, it would be hello, hello, space, hello. Try to get this one working. Don't put an extra space at the end there. And then that'll kind of give away the answer to how to make 42 of those. Okay, so please help each other. Get some practice with the Python syntax, and let me know if you have any questions. A few minutes to try this. Let's figure that out. Maybe it's going to be the answers used in your computer today. Another minute, please. Give that a try. All right. So, did any brave souls want to share how they got it? Let's see here. The secret really is, how do you make it like work 3 times? What's the answer there? Any thoughts? How'd you do it? Mm-hmm. All right, so I'll give you 43 hellos though. So you're off by 1. That's the right answer though. Yeah. What about you? There you go. Very good. So there's essentially 2 separate strings that you're bringing together because you can't, if you multiplied this one a few times, it had to include the space, and you don't want it at the end. So yeah, great job, both of you. That's exactly what you want there. It's essentially, if you just change 42 to 3, the idea is you want to somehow concoct this string, everything but the last one, and then the last one, because this one is repeated, right? You have this thing repeated twice. Hello space, hello space. And then one more gives you how many you wanted. So it's hello space, and that's 41 times we want that. And you can put this in parentheses. You don't really have to, I don't think. And then the final 42nd hello gives you, and then you have control over that one because it's separate, and you just don't put a space at the end of that. So there's the closing quote, no extra space. Okay, any questions about that? Yeah. Hello times 1 is just hello. That's just it once. You don't have to say it if it's just one time. Good question. Any other questions? Yeah, so that's essentially it. That's the answer for that one. Hopefully that's getting your mind churning. Let's actually make real programs now, because this is the REPL, right? It's not a real Python program. I haven't really given you anything useful yet. Just we've been doing math and string stuff. Let's talk about printing variables and getting input from the user. So Python programs are not just single statements at a time, single lines at a time. A line is called a statement, by the way, in Python. A Python program is a file that contains a bunch of lines all to be run in order, sequentially. It's not just do this thing, then I'll type the next line, then I'll type the next line. No, give them all at once and then run the whole thing. Okay. So it's a file, and we're going to write our programs in a file called program or something. And the common extension for Python programs is .py. If you save a file in idle, it will automatically use .py. So yeah, that's that one. And every line that you write in your files, they execute one line after another. Okay, so let's make a Python program. Our first Python program, of course, should be the one that prints hello to the screen, because that's how you're supposed to learn a language. You learn how to do the hello world program first. Right? So we're going to use the print function eventually, but here's the idea. I'm going to go to File, New File in idle, and this will give me an actual program file to edit. File, New File, and then I can write a bunch of lines. It's just a blank file right now. Then I can write a bunch of lines of Python to all execute in order. That's the idea. And so I'll save this. I'll save this somewhere nice for us. I'll save it on my desktop. You can save it wherever you want, but I want to give this to you later, so I'm going to put it in a special place. Let me remember what lecture we are. This is lecture 13, apparently. So I'll make a folder for that. Oh, there we go. Lec 13, and so I'll be able to give this to you now. And I'll just call this, oh gosh, what do I want to call it? Let me quickly figure that out so I can be consistent. This is going to be lecture 13, and I'll just call it, Hello World, helloworld.py, and it already has the correct .py extension when you click save. So it's like helloworld.py, saved wherever you saved it, and so now it's a blank file. All right, and the way that you run stuff in the file, the way that you have that file write stuff to the output, you use what's called the print function. And so here's what you do. Here's how the print function works. You say print, and just like type, you put what you want to have happen in between parentheses. In between the parentheses is, well, what you want printed, because this is the print function, we say. So I'll say hello, or whatever you want to call it. And so what this will do is print hello to the screen, all right? Because this is not, this is just a file. If I press enter, it's not going to run anything. That's only the REPL. This is just a normal program now. All right, so I can say print hello, comma, space, world, exclamation point, end quote. And if I save the file, now this is a program, and I can run every line in it. There is only one. I can run every line in it with this run window. So I click run module. Every file is called a module in Python. And then it runs the program. And so there is its output, hello world. So I just ran my program. Isn't that fun? It ran all the lines in the file. There was only one, though. And so it prints hello world out into the output window. Any questions about that? That is our hello world program. Yay. So let's see here. Print, by the way, it's called a function. Type was also, it's something called a function. And a function just does something that's already been written for you. Somebody wrote whatever print does. You can just use it now, all right? And so what we did is we called the function. We called the print function. That's the terminology. So to call a function, you have to say its name, like print. That's the name of the function. The name of the function. And then in between those parentheses, you put all the things that the function needs to run. Print just needs to know what you wanted to print. And so it's going to take one thing, and that thing is called an argument. Print is going to take one argument, like you're yelling at it. Hey, please work with my string, this one. We give one argument to the print function. It just needs to know what we wanted to print. Okay? And so in general, when you have a function, here's how you use it. You say its name, of course. In between parentheses, you give all the things that it needs to run. So it may take multiple arguments, not just one, and you'll separate those with commas. All right, so the arguments go between those parentheses, separated with commas, and sometimes functions aren't meant to be called on a line by themselves. They give back an answer. And you can save away that answer if you use this kind of assignment statement, and I'll talk about that later. This puts a value into a variable. Okay, so that was the print program, the hello world program. We're calling the print function with one argument, we say, and that's the string that we wanted printed. Is that good still? All right. Just like in Scratch, we wanted to be able to tell ourselves when we come back and look at our program later, like what we were thinking, and so we include a lot of comments. Here's how you write comments in Python. There's no sticky notes anymore. It's just you write text. So if you want to write a single line comment, you use the number sign. Everything after the number sign, Python doesn't care about. It's just words for you, the programmer. All right, so that's a single line comment. And so this, if I put a number sign up here, everything after the number sign is a comment. Python doesn't think it's code. It's just for us, the implementers. This is a comment. It's not Python code. Everything after the number sign is a comment. And you can put comments on lines after real code. It's just after the number sign, Python stops caring. And so we can remind ourselves for fun, like, oh, this prints hello world. Not that we would have forgotten. All right, so you can write comments on the same line as code. It just needs to come after, because everything after the number sign is discarded. All right, so that's a single line comment. Sometimes you want to write multiple lines of comments, and you don't want to put a number sign at the start every time. That's kind of a lot of work. So you can write a multi-line comment by writing 3 quotes. If you write 3 quotes, that starts, it's just like a weird-looking string. In between pairs of 3 quotes, that makes a multi-line comment. This is, I don't know, let me break the line, a multi, you can see how it's colored different. Multi-line, you can put as much white space as you need. Comment. And then you end it with another set of 3 quotes. So if you don't want to type the number sign every time, this is how you make a multi-line comment, right? And again, nothing changed. The only real piece of code is the print. And if I run this again, I get the same answer. The comments are just for us, the programmers. So remember what we were doing. Any questions about that? Those are comments. All right, let's talk about variables now. Variables are very, very important. You don't want to rewrite everything a bunch of times. You want to save stuff away in variables like we were doing in Scratch. Here's how you do it. You can put anything you want inside of a Python variable, and every variable has to be given a name. There are certain rules to writing variable names. Only some are valid. When you write a variable, its name can't have a space in it. It could in Scratch. That's why I didn't use spaces in my Scratch variables, just to prepare you for this moment. Variable names in Python can have spaces. They can't have special characters either. Like you can't have a variable that has the plus symbol in it or something like that, because it thinks you're adding things at that point. So variable names, they have to start with an underscore or a letter, could be capital or lowercase. And then after you write your first character of your variable name, it could be, again, another underscore. After that, you can follow it with as many underscores, lowercase characters, capital characters, or digits as you would like. So this is saying that variable names also can't start with a number. Have to start with an underscore or lowercase letter. So here are some valid variable names, like x, of course, is a valid variable name. Underscore, underscore, x, underscore, underscore, score, valid variable name. Underscore blah 42, valid variable name. But 42 blah, that doesn't count. That's not a good variable name. Python will complain because it can't start with a digit. It has to be underscore or a alphabetic character. Right? Those are valid variable names. And the way that you give a value into a variable, you can create it at the same time, is you use what's called an assignment statement, which has an equals sign in it. This is what it looks like. You say variable name and then an equals sign, and then you write on the right-hand side whatever you want to put into the variable name. It could be some big thing that needs to compute a final answer. All right? So it's going to evaluate this complicated expression, whatever you put on the right, and it's going to shove the answer into the variable. All right? So this line, for example, x equals 42, that will create the variable x and put 42 inside of it. So that line, when you run it in Python, it makes a variable holding 42, just like in Scratch. All right? Here's a fun idea. X equals x plus 1. This is a valid line of Python code, and this tells us the idea. Remember, it's always right to left. It's do the thing on the right, put it into the variable on the left. So that's why this is not ambiguous. It's going to do the x plus 1 first, and then shove the answer into x. So the right-hand side, RHS, gets executed first. And that's why this is not ambiguous. It's executed first, and then it puts the answer into the variable that you put. It could be the same one. All right, so this computes based on x's value of 42 right now. This will compute 43, and then it's going to put the 43 back into x. So this is how you increment a variable in Python. You say x equals x plus 1. Any questions about that? It's a little weird, but that's how you do it. So I'm going to make another file. So you can have a bunch of separate ones. I'll go to File, New File, and I'll call this one vars.py. You can call it whatever you want, though. And so this is a separate program file, and I can say x equals 42, and then I can use x everywhere instead of 42. Now I can say print x, and so if I run this program, it's going to run the lines in order, remember? So it puts 42 into x, it makes that variable, and then the one line that actually produces output is the print line. Print x gives me 42 in my output. We good with that? And like I said, x equals x plus 1 is fine. You can do that. Now if I print x again, everything is happening in order. If I rerun the program, now it prints 42 first, because that's what x was originally. Then it goes to these lines, makes x 43, then prints the 43. That's why we see that output. So all the things you could do in Scratch, you can do in Python. You just have to worry about the names, I guess. Any questions about that one? Let's see. A very common thing that we did in Scratch was ask the user to control our program. Please give me some input, user. Type something for me. And so in Python, getting input is another function call. Everything's a function call. So in Python, there's a function called input, and that gets you input from the user. And so what it does is when you call input, it takes one argument, input. It takes one argument, and the argument is a string that is the prompt you want to show the user while they're typing whatever you asked for. So, for example, you could be like, enter your name as a string. Enter your name, colon, space, or something. And then it'll show this string to the user as we're asking them to type something. That's what it does. And then once input finishes, we got something from the user. It gives back its result. It doesn't print it or anything. It gives back its result. And it's our job to save that away into a variable, maybe, like resp or something. It'll shove whatever the user's answer was into this variable now. It gives back the user's response. All right. One thing to notice is that input always gives back a string, a str. Even if the user types a number, you're going to get the number in string form first, which is unfortunate. And you might have to do some conversion if you wanted to do math with it. Okay? So the easiest way to show you these problems and these ideas is with another example. So let's ask the user for their name. Let's do this line. And then we'll be like, hello, user. Something like that. So I'll, again, make another new program file. I'll call it something different. I'll call it like getting input.py. And here's how I'll do it. The very first line is going to be me asking the user to enter their name. So I'll be like resp input. Hey user, enter your name, please. And then I want to save away the result into a variable, so I'll say resp equals that. And now I can get that answer back from the user and I can use it, like print resp. If I wanted to, it'll just print whatever I got back. And this will allow us to do some cool stuff. So if I run this program, watch what happens. It's going to run the input line. So it's going to wait here, get an answer from the user, and you see that we have a prompt now where we could start typing. And I can say Latin. And I hit enter, and what happened is it took that result and put it into the resp variable. And so we have this going on now. The resp variable got created, and it holds the string, assuming I typed my name. It holds the string Latin, and then you can use it later. Like here I am printing it, printing resp. See that? You can make it cooler though. You could be like print hi space Latin, something like that. And then maybe you can have an exclamation point at the end of that. That'll be fun. So if I run this program now, watch what happens. It'll take the variable that we put the answer into, and it'll put some words on the side of it. And so now it's going to print back, hi, Latin, with an exclamation point. Isn't that fun? So that's how you can build up a bigger string with a plus, enter your name, all that fun stuff. It's very common to want to print multiple things in Python, so the print function is overloaded. It can take as many arguments as you want, and it will space separate them for you. So instead of printing hi plus resp plus exclamation point, I could have done this. I could have said hi, comma, no space, because it'll add it automatically. And then between commas, I input all the things I want space separated in the output. This will look weird for the exclamation point, though. So this will also do something. It'll print all these things with a space between them. That's what multiple arguments work as in print. And so it'll print hi, comma, space, Lawton, space, exclamation point, which is kind of funny. I guess this is correct French. Like, they put a space after or before their exclamation points, but not quite correct English. So maybe this way was the better way anyway. But yeah, print, let me just spell that out. There it goes. Print can take as many arguments as you want. It's going to space separate them in the output. It space separates them when it outputs things. Okay, that's the print function. And yeah, likewise, you can ask the user for a number, right? But when you get something from input, like, it's going to always give you back a string. So like, what's the type of the thing in resp right now? Let's print that. So look at how this call is working. I'm first computing the type of resp, which is like int or stir or something, and then I'm printing that answer. See how it's doing that? It's like this is getting replaced with its answer, and then I'm giving that to print. There's an order going on there. Oops. So let me run this. Enter my name, Lawton. It's a stir. It's always a stir, even if I typed a number to Python. So this is going to do some weird stuff right now. For example, let's ask the user. Let's throw this into a num variable. Hey user, with input, enter your favorite number. Colon space or something. So, and then if I print the type of num, watch, it's still a stir. It's still going to be a stir. I'll rerun this with F5. Lawton, enter your favorite number, 42. It is a stir. The type of num is a stir. So I put into num whatever the user gave me. The user gave me 42, but input always gives you back a stir. So it's the string 42. Isn't that funny? That's going to mess you up one day. So that's why we're talking about it here. And so if I wanted to do math with this num variable, I couldn't immediately do it. I couldn't be like print num times 2, could I? Because watch what will happen. Enter your favorite number, 42, and then it prints out the answer of num times 2 as 4242, because it's like, take that string, make it twice. We wanted 84, right? So if you want to do math with the number that the user gives you, if it's a number, you need to convert its type from stir to int or to float or to something that is numbery, okay? So that's not what we want. Instead, we want to convert that type. So let's convert a string to a number with either, you can call the type like a function. You can say int on the variable, or you can say float on the variable. Call it with that as an argument, and it will convert that string, if it can, to a number. So I'm going to say int num, and that will convert num into an integer. So int num will make the integer form of the number. So I can save that into another variable if I want, like num as int, and that will have the correct type. So num is only a stir. We must convert it to an int. Okay? And so this is, now I can print num as int times 2. And now it'll actually work. Now num as int holds the integer form of the original number. Save. Well, no, I didn't type my whole name, whatever. 42, and now it's 84. You see that? I had to convert the types to make it work. Any questions about that? That's definitely something you want to go back and you practice, but input always gives you back a string. Remember that, otherwise weird things will happen. Okay, let's see here. Yeah, I just talked about this before, but print can take as many things as you want between commas. You can take as many arguments as you want to give, and what it will do is it will print those out all on one line, space separated. So if you call print like this, it'll print out arg1, and then a space, and then arg2, and then a space, and then arg3, whatever those values are. And so that's why we saw this answer here. It was always space separating things. That's totally fine. Okay, so if you have multiple things you want to print, that works. Yeah. So you can always use plus if you want to fully control the output. Sometimes you don't want a space, like between the word and the exclamation point, perhaps. Okay? All right. Yeah, if we're still okay, I have one last main section. Let's talk about something called the math library in Python. So there are multiple libraries. This is why Python is one of the most popular languages. It gives you a lot of libraries to use. And a library is just a bunch of pre-written code. Somebody else, some smart person, wrote for us that we can use in our own code. So a library is a bunch of pre-written code. Pre-written code that you can use inside your own programs as much as you want. You don't have to reinvent the wheel. It's already been done for you. That you can use inside your programs. That's what a library is, and there's many libraries in Python. The first one I'll show you is math. And there are documentation pages on what the math library provides to you. You can go to this link, or you can just search Google for Python math, and the first link is going to be the documentation page on the math library. So if you click that, you'll see here's all the things that math gives you. It gives you all these little functions. Some of them will be will be something you know about. Like this will do the greatest common divisor on some numbers. This will compute the what are some ones that you understand? This will compute e to the power of something. This will compute the logarithm with a given base. This will compute the log base 10 logarithm. This will take one thing to the power of another thing. This will compute the square root. So a lot of things that you would like to have, right? Also sine, cosine, tangent, all those mathematical functions you'd like, those all exist, and they're defined in the math library. Okay? So that's where all those things live, and let's use it. So to use the math library in Python, you have to tell Python that you want to use it, and that is called importing it. You have to say, I would like to import the library, please. And so you say import math at the top of your program, and that tells Python, I would like you, for the rest of this program, to know that I am using the math library. Have it available for me, okay? And then after you say that, you can use any math function that's been defined for you, or variables that's defined in the library too, and you have to prefix them. You have to prefix them with the name of the library. So if you want to use math's pi variable that has pi already defined for you, you have to say math.pi. That's how you get at math library stuff. That's a predefined variable, and then a bunch of functions also exist, of course, like math.square root. You have to say, I want the square root from the math library. I want the sine function from the math library. Okay? So let me show you that as an example, and I'll make a new file. And I'm not going to name it math.py for a reason. I'll call it mathstuff.py. Okay? My first warning for you is never make a file with the same name as a library, because secretly, the way that libraries are being imported in Python is that it's looking for a file called math.py. If you name your own program math.py, it will look there instead of the default place for sine and square root and pi, and it's not going to find it. Right? So that's the problem. If you run into errors, check your file name. Don't call it the same name as a library. So import math. This is a file called mathstuff. All right, it's not called math.py. So once you say that, now you're allowed to use the math library things. Now we are allowed to use all the math library functions. Okay? So let's do some cool stuff now. Let's see. What do I want to do, and then what do I want to ask you to do? So let me make sure I'm not gonna mess that up. Yeah, let me just show you a few things. Let's see here. So here's math, and then I can use it as much as I want. I have to prefix it with math dot. Let me just spell things out here so that we don't forget. Import math, that's making all the math library functions available. Makes math library functions available to use. And the way you get at it is you say math dot what you want. So it's always the library that you import, you have to prefix it, like with the name of that library name dot the thing that you want to use inside of the library. All right, so that's how you use the library. And so now let's use some of these functions. Let's calculate the area of a circle, for example. A circle with radius, let's say 4.5. So you remember the area of a circle equation? It's pi r squared, pi times r to the power of 2, essentially, in Python lingo, Python syntax. So let's spell out some variables. Like our radius for this example will be 4.5. Our area then is going to be pi. Pi is defined in the math library as, as math.pi. So many windows, sorry. Not that one. There we go. And then the area then is going to be pi times 4.5 squared. So math.pi times 4.5, but that's in the radius variable. Let's use that. Times radius to the power of 2. That's going to be my area. And so now I can print the area. And that is one nice thing that the math library gives you. It gives you pi immediately to use. So I run this program. Apparently the area is 63.6-ish. Okay. Any questions about me using the math library? Let's use square root now. Square root is a function. You give it what you want the square root of. It takes one argument, and it computes that square root for you. Like you can say math.square root of 2 or something, and it will compute that for you. So let's use that in our program. So let's calculate the square root of a number that the user gives to us, that the user types. So let's do it like this. Let's get a number from the user. So input, hey user, please enter a number, colon space, to give a nice little prompt for them. We want to save the answer that we got, whatever the user typed. Let's put that into the num variable. And we can calculate the square root of both whole numbers and numbers with decimals in them. So let's use the most generic one of those. We have to convert this from a string, right, to a numbery type, so we can do math on it. So let's convert num from a string, which it is right now, to a float, just in case these are used decimal places. So float of num, we'll convert that to a number. Now I can do number stuff. I'll save that in like num as float or something. So now I have a number that I can actually do math on. And now let me compute the square root of that number. So it's going to be math.square root, num as float, and then I want to print whatever that answer is. And so I can just wrap this in a print call. It'll do the inside first. Okay? So let's run this. If I type 2.0, it will give me the square root of 2, of course. If I rerun the program, maybe, I don't know, 49.0, it'll give me back 7, of course. And the reason we took it as a float is because maybe the user wanted to figure out the square root of 0.5 or something. That's a decimal number. We needed the float type for that. Okay? And so that's us computing the square root of that. Any questions about that? Let's see, one more. Let's also use the sign of that number. So you can use math.sign. It takes one argument and computes the sign of that argument. Assuming it's in radians, I think. So let's compute the sign of the number. Sign of num is, that'll be a new variable, equals math.sign, whatever that number was. Num, of course, we need it in number form, so we'll use num as float again. And then we can print the sign of comma num as float, print out that one, is, it'll space separate all these answers, right, when we print it. And then we give the answer, sign of num. That's kind of cool. And so now if I type 3.14, it'll compute the square root of that, and it will tell me that the sign of that number is pretty much 0. There are some precision issues in Python. You don't have exactly perfect numbers like you should have. And also, this wasn't exactly pi anyway. So the answer really isn't 0. It's 0 to 2 decimal places, no matter what, right? So I should have typed pi with more decimal places if I wanted a better answer. Anyway, okay, but that's beside the point. So you can compute the sign of the number, store it in a variable, and print it out in a fancy way. So just getting some practice with all the stuff we've been talking about. Any questions on any of that? All right. I think I'll give you this question. That'll be our last question for the day. Here's, let's see, can I give you some of this code? Here's some relevant code that you might find useful while you're working on it. But I would like you to write a program that takes two numbers from the user. So you're getting two things, and call them A and B, let's say, and it's going to compute the square root of a squared plus b squared. So this is like finding the length. Like if a is equal to 3 and b is 4, this is going to come up with the number 5, right? So take two numbers from the user and plug them into this formula, see if you can program that, and that will give you the length of that hypotenuse of that triangle, for example. That's a useful program to write, right? So see if you can figure that one out. Make a new program, have it ask these are for two numbers, make sure they're numbers after you get them, then you can do math stuff with them, with the math library. So please help each other. Give you a few minutes to think about this one. Take about 1 more minute to try it. I'll show you my answer. All right, that is my timer. So let me show you how I might do this. So we're going to get two numbers from the user and then compute this fancy equation on them. So I'm going to make a new file. And essentially that formula is calculating the hypotenuse of a triangle with those side lengths, or the right triangle with those side lengths. So I'll call this hypotenuse.py. And I'll import the math library, like we did. Import math. So now I can use the math stuff because I need square root, right? And now I need to get two numbers from the user. So I need like A and B. A equals input, enter A, I guess. Just whatever prompt you want to give the user. Same for B. And initially, those are strings. You can't do math on strings. What you get back from input is just a str. So you need to convert those to numbers, and because the user might not give you a whole number, maybe let's make them floats. And so instead of making a new variable to have the conversion and place the converted thing into it, I could just call float on whatever input gives me back. And that'll put into A just the floating point version, the decimal number version of this input string. See that? It's a bit cleaner that way once you get used to it. So just get the input from the user, that'll be this, take it, make a float out of it, please. Convert it to a number format. Isn't that nice? And then you can calculate the hypotenuse pretty easily. You can be like, it's going to be the square root of a squared plus b squared, so you need a squared, and you need b squared. You need to add them together, and then you need to take the square root of that. So it'll be math dot square root of that whole thing. See how I'm writing that? And so if you print that, that should be the answer. Enter A, 4, B, 5. Then we get 6.4 apparently. Oh, sorry, it was 3, 4, 5. That was this one of the secret cool ones. 3 and 4 make 5. Cool. Yay. So that'll work for any A and B. It'll always do a squared plus b squared and then take the square root of that. Any questions about this program? So, the very last thing before I get into other things, we have plenty to talk about before we go today. I just want to very briefly, we'll have to gloss over this one, I want to talk about a program called Python Tutor. It's a website. If you go here, if you follow this link, I only have like a minute to talk about it because I got more things to tell you about, but it gives you a program. This program cannot take input, so you'd have to hard code your input away, but it will it will show you exactly how your program executes, like x equals 4, y equals 5 plus x equals x plus 1, print x times y or something. You put whatever program you have here and you click visualize execution. What that does is it gives you your program, it puts little arrows, and it's going to draw a picture of exactly what's going to happen as Python runs this program. It's like, all right, x equals 4, that makes an x variable. Now it holds 4, it's drawing a box. Y equals this, and it's showing you how it makes 9. X equals x plus 1, now it's 5. And then it prints x times y, and that's the output, 45. This is going to be great. Once you write more complicated programs, you can watch how they work. I think that's a great little resource. So please try that. Unfortunately, I don't have enough time to talk about it more, but please ask me questions about it. Come to office hours, maybe next time even, because I have a few more things to talk about before we go. But that's called Python Tutor. You can use this link here or just search for it. So yeah, before we go, I have several things we need to talk about because this is the only day that we can talk about it since we have the midterm next time. So let's see, you have an essay due this week, so you need a new essay. We are in the middle of the semester. And then also, I want to give you your first extra credit assignment. So, gosh, so many things to talk about. First of all, your next essay. It's going to be a short one, 500 words. You're welcome. This will be due week 10, apparently the 14th. Here is your essay requirement. Please read this article. I have a link. It's about a machine called the Therac 25, and I'd like you to write a response to it. It's a very unfortunate machine, sadly. So there's some issues there. You'll read about them. It's a very sad story. I would like you to do the following. Highlight any false assumptions that were made by the companies who made this thing. You might want to consult the Wikipedia page as well on the Therac 25 machine. Tell me about any false assumptions that were made by the companies as they were making it, and also tell me what you would have done differently to prevent this horrible thing that happened. I assume you haven't really heard about it. It's not very recent, but it was a very bad thing that happened with this machine, sadly. So please write an essay responding to this prompt, these directions, following those, of at least 500 words. And I don't have to, I'm not going to give you a citation requirement, but you might feel it necessary to cite the article or some other source that you find. All right? So read the article and talk about the issues, how you would have prevented what went horribly wrong with the Therac 25. All right? 500-word essay. Any questions about that? So that'll be your next one. Nice short one after the midterm. Let's see here. Yeah, so that's all I wanted to say about that. Also, we are in week 8. There are 16 weeks of classes, 17 if you count finals week. So we're essentially in the middle of the semester. So I like to do this. I like to give a mid-semester feedback form to you, my students. so that if there's anything going wrong with the class, you can tell me about it, and we can fix it while you still have time to benefit from the change, right? So that's why I do it. So if you click this link, click here to take the survey, it's just a Google form. I have no clue who responds and tells me what, so it's completely anonymous. It's not for a grade, but I would appreciate it if you filled this out. These kinds of things. Tell me what I should stop doing, what I should keep doing, what I should start doing. What would you like to change about the class? This will help me improve the class for you and then my future students in future semesters. So I'd appreciate it if you filled out this form. Again, it's not worth anything. I can't force you to do it. I don't even know if you did it. It's completely anonymous. But I would appreciate your feedback. So that's that one. And then finally, I would like to give you an extra credit assignment. So this one is worth up to 5% extra credit. If you already know JavaScript, you better talk to me because I don't want you to get an easy 5%. But for everyone else, here is an extra credit assignment for you. I'm only teaching you Scratch and Python in this class. It would really help you as a budding programmer to learn as many languages as possible so that you can understand what's similar and what's different, right? So here is an extra credit assignment that's worth up to 5% extra credit on top of your final grade. So here it is. If you go to this Khan Academy course, I think you'll have to make an account, and then you will complete some of these lessons on JavaScript, right? So you'd follow all these, intro to programming, drawing basics, all this stuff. If you would like, and every time you complete one of these little sections, you'll click on all of these, right, in order, and you'll do them. It should like mark it on your account as having been completed, like it'll turn a different color or something. That's how I'll know that you did it. You'll send me like a screenshot of that. So all these like will change colors or something to show that you've completed them. Like this one shows that I've made some progress there or something. Okay, so if you go there and you do these things, you make your account, here is how you can get extra credit. So for 2.5% extra credit, I would like you to complete every lesson / project / challenge, so everything in order. Oh gosh, I have too many windows open. No, it's just this one. Every lesson, project, challenge, all these things, up to and including the variables section. So all the way up to variables. So do all these up to this. All the way down to review variables. If you do all those, I'll give you 2.5% extra credit. If you want the full 5%, you got to go a bit farther. Complete all of the challenges, lessons, whatever, up to and including the interactive program section. So all the way down to after variables, animation basics, all the way through interactive programs. So all of these things. The very last one is this challenge here. Okay? Any questions about what I'm asking you to do if you would like to do the extra credit? So that's what I want. And if you do it, please, as usual, submit a video where you just scroll through and show me that all the colors have changed, that like you have the 100% on each of those things that I asked you to do. Okay? That's how you'll prove to me that you did the assignment. Yeah. So if you already know JavaScript, let me know and we can find you a similar language to learn with a similar difficulty. Like maybe we can use the Code Wars website if you've heard of that. We'll figure something out for you as well. But I want to give everybody the chance to get some extra credit if you would like it, because I promised it. So that's that one. This will be due about a month from now, March 31st. Any questions about it? Or anything else we talked about today? So essay, feedback, extra credit. I believe that is everything that I wanted to talk about. Remember that we have the midterm on Wednesday, and I'll see you then.